Hey, seventh graders. Your test is Wednesday this week. So this video is your test review on Tuesday. So I sent you the practice problems. So I would hope that you would do the practice problems on your own and then check with the video to make sure your answers are correct. That would help you the most. Also on Wednesday, once you've taken the test, so please do that on Wednesday, and all your other grades are due by midnight on Wednesday for this semester. I have to verify your grades Thursday morning, so it's very important that you realize I can't accept any grades past midnight on Wednesday. All right, so let's get started. If you have any questions on any particular problem, let me know and I will go over the answers with you. So number one, what is the scale factor of the dilation that was performed on this triangle? So one very important thing to do is make sure you start with the original. So if you tell me the answer that if you go from the image back to the original and you figure out the scale factor that way, you're going to get the inverse of the scale factor, and that will not be correct. So the red triangle in this situation is the original, and the reason I know that is because the blue ones have the little prime symbols. So remember how you figure out what the scale factor is. You do image over original. So we could either compare coordinates or we can compare side lengths. So it doesn't matter. So let's just do the coordinate of A prime. So A prime is at 4, 6. So let's just think of this as a coordinate, 4, 6. And the original A is 2, 3. So if we think of these as two separate fractions, 4 over 2 and 6 over 3, they're equal, right? So that means the scale factor is 2. So the blue triangle is twice as big as the red triangle. So don't forget, if you get that backwards, you're going to have the scale factors one half, and that's not correct. All right, now let's look at number 2. If triangle A prime, B prime, C prime were reflected over the y-axis, write the coordinates of A double prime, B double prime, and C double prime. So we're looking at the blue triangle. If you reflect over the y-axis, that means the x-coordinate changes signs, but the y-coordinate stays the same. So whenever you have your line of reflection, you want to move toward that line. So we would move toward the y-axis. We would go 1, 2, 3, 4 places, and then we would continue moving 1, 2, 3, 4 places. So there would be A double prime. For B double prime, we would move 1, 2, 3, 4 spaces, 1, 2, 3, 4. So here's B double prime. And C, we're moving toward the line of reflection. So 1, 2, continue going 1, 2, and there's C double prime. And we would connect those dots. And we would get something like that. So what are the coordinates of A double prime? That would be -4, 6. B double prime would be -4, -4. And C double prime would be 2, -8. So the y coordinate did not change, but the x coordinate became the opposite sign. Number 3, what is the relationship of the angles that are marked? So basically they want to know what is the relationship between this angle and this angle. So those are alternate interior angles. And what is true about alternate interior angles? They are congruent. They are congruent. So when it tells us to solve for x, that means that angle 4x minus 10 is congruent to or equal to 58. I think that was an 8, wasn't it? It's an 8. I wrote over it. I couldn't even see it. Yes, it was an 8. All right, so that means we're going to add, so to solve for x, we're going to add 5 to both sides. So then we would have 4x is equal to, 53. and then we would divide both sides by 4. What did I write? I wrote 10, you guys. Oh my goodness. Where do I just make up my own numbers. I don't have any sense. So we would add 10 to 58 and we'd actually get 68, 68, and then we would divide those sides by 4. So 68 divided by 4, 68 divided by 4 is 17, 17. So X is equal to 17. That doesn't mean 17 degrees, right? The degrees is 58 degrees. So this 4, let's double check it. This 4 times 17, 4 times 17 minus 10 equal 58. Yes, it does. So we know our answer is correct. All right, good. Number 4, what transformations create congruent images? So congruent images would be what? Translations. What else? Reflections. And one more. And rotations. All right, letter B, 4B, what transformations create similar figures? So that would be, of course, dilations. Number 5, describe the combined transformations that occurred from the original figure to the second image. So let's find our original without any prime marks. That would be A, the red one down here, right? So polygon ABCD. So first, the first thing it did is it got flipped up here, right? It's flipped up. So the first thing that happened was a reflection over which axis? The x-axis. And then we went from, let's look at D prime. So we went from D prime to D double prime. So what was that move? It was just slid over, right? So it was slid left and then it was slid down. So we're going to say a translation. So we moved 1, 2, 3, 4 left. And then we went from here, we went down 1, 2, 3, down 3, down 3 units. We could also say we moved X, Y, translated it, left 4, and then down 3. So either of those answers would be good answers. All right, I hope you guys are getting yours right. Number 6, angle MNO is rotated 90 degrees counterclockwise. So 90 degrees counterclockwise coming down here, right? About the origin to form M prime, N prime, O prime. What is the measure of, basically measure N? That's the second letter, right? So it's asking, what is the measure of angle N? Well, honestly, I don't have enough information to get a number for angle N. Like, I don't know what it is. I could guess it's about 45 degrees, but I'm not sure. But what I am sure is that the measure of angle N prime is equal to the measure of our original N. So this is a true statement. So even though I don't really know the exact number, I know that it was rotated 90 degrees, but that doesn't tell me that angle N was a specific number. But I do know that once it's rotated, N prime will be the exact same measurement of N, and the original angle N. So I hope that makes sense to you guys. So number 7, there has been 2 transformations. So the previous page, it showed us the second image and then the last one. On this one, it doesn't show us the second image. It just shows us the first one and the last one. So obviously we can see that this figure has been flipped, right? It's been flipped and then it's been slid in that position straight down. So that tells us that we have a reflection. So the first thing that happened is a reflection over which axis, guys? It was flipped from here to here. This would be B prime. This is actually B double prime. So a reflection over the y-axis. Make sure you don't get those axes mixed up. And then, so if we started out at -2, 4, when we flip it, we go to +2, 4. And then the second thing that happens is we slid it down, right? We translate it down, translate down. Let's see, 1, 2, 3, 4, 5 units. That's what happened. We reflected over the y-axis first, and then we translated down 5 units. Number 8, here we have figure MNOP. It was transformed to M prime, N prime, O prime, P prime. So it wants to know the best description of the relationship. So is the original bigger than the image? This is what this is saying. The original is bigger than the image. No, of course not. The measure of angle O, so here's O, is that equal to M prime? No, O is going to be equal to O prime, so that's not true. How about O is equal to P prime? No, because it was flipped. So O is still equal to O prime. So look at the last choice. Figure MNOP is similar to the prime figure. Well, I don't love that answer. I would prefer the word congruent to, but since we eliminated the rest of the choices, those are definitely not true. This one is the best answer, okay? So even though I prefer the word congruent, it's letting you know that all congruent figures are also similar. Not all similar figures are congruent, but all congruent figures are considered similar as well. So just wanted to go over that one because you may come up with one of those and go, wait a minute, the answer is not here, but that is the best answer. All right, let's look at number 9. So a pair of parallel lines is cut by a transversal. Whoops. What is the measure of X? So the first thing I wanted to do is identify what's the relationship between this angle together. If those were one angle, what would that angle and this angle have in common? First of all, they're alternate interior angles. We had another one of those, didn't we? And since alternate interior angles are equal, that means that angles X plus 20 must be equal to 80 degrees. So to solve for X, we would subtract 20 and we would say that angle X is 60 degrees. This angle is 20 degrees and that's equal to 80 degrees. Number 10, what's the relationship between these two marked angles, this angle and this angle? They are vertical angles. Vertical angles. And what's true about vertical angles? Vertical angles are congruent. So to solve for X, we take the first angle, mark 2X plus 6, and set it equal to 96 degrees because they are congruent. So to solve for X, we're going to subtract 6 from both sides. And then the opposite of times 2, we divide both sides by 2. So X is equal to 45. Not 45 degrees because the entire angle is 96 degrees, right? But X is 45 degrees. So 2 times 45 is 90 and 90 plus 6 is 96. So that is correct. All right, you guys, that's it. So make sure you remember you must take your test on Wednesday and then make sure you know that you have to get all that graded work. If you have any zeros, which you should not, but if you do, all your work is due by Wednesday midnight, okay? If I don't see or talk to you guys, obviously I probably won't see you, but if I don't talk to you this week, I hope everyone has a wonderful, wonderful Christmas and a wonderful New Year. And as they say, I will see you next year. See you guys later.